Hello everybody, welcome to note quiz number 3 on equations. In this note quiz we'll actually solve equations of 4 different types. We'll look at quadratics, we'll look at equations that are rational, look at equations that have radicals in them, and finally some reducible to quadratics. When solving quadratic equations there's actually 4 different ways to do it. We've got factoring, the square root method when it applies, completing a square, and of course our quadratic formula. So for this problem here, we're going to actually go in and we're going to use a factoring technique. And so for the first one, you will notice it is pre-factored. We've got the 6x plus 5, that equals 0, or perhaps it's the 2x minus 3 equals 0. Here we are using what's called the zero factor property. So for the first one, subtract 5, and we get 6x equals negative 5. Divide both sides by 6. And we get negative 5/6 for our first solution. For the other equation, we add 3 to both sides. So we get 2x is equal to 3. And then, of course, divide both sides by 2. And we get 3/2. So the two solutions are negative 5/6 and 3/2. Remember again that you can always check your solutions by substituting into the original and verifying that you get a true statement. For this next problem, you will notice that it is not in the correct form to be factored. So first thing we're going to do is put it into the standard form, which means we're going to have leading the x squared, followed by the x, and then the constant. So we're going to subtract 13x from both sides. That takes us to 6 times x squared minus 13x minus 15 is equal to 0. We're now going to factor it. To kind of review some ideas from before, we're going to use the grouping method on it. That's taking that 6 and that negative 15, and we multiply those together. We are going to get a negative 90, and now we need to find two numbers that multiply to make negative 90 and have a difference of 13. And there's a lot of different numbers to consider. You look at 1 and 90, that's not going to do the job. We can do 2 and 45, 3 and 30, 4 won't go in, 5 will go in, and let's see, how many times does 5 go in? I think 18 times. And that right there is our pair. So rewriting, we've got 6x squared minus 18x plus 5x minus 15 equals 0. We now factor by grouping. In the first, we can take out a 6 and an x. Leaves us with x minus 3. In the second, we can take out a 5. Leaves us with x minus 3. Take out the common x minus 3. Leaves us with 6x plus 5. So for this equation, we've got either x is equal to 3 or x is equal to negative 5/6. So 3 or negative 5/6 are the two solutions. For the next problem, we'll go through and factor again. Resist the temptation to divide by any y's. We can't do that. So subtract 12y from both sides. We get 40y squared minus 12y equals 0. We can factor this by taking out both a common factor of y and a common factor of 4. If we take out both of those, we are left with 10y minus 3. We set each of those factors equal to 0. Divide both sides by 4 in the first equation to get y equals 0. In the other equation, we will add 3 to both sides, and we get 10y equals 3. Dividing both sides by 10, we get 3/10. So the two solutions are 0 and 3/10 for that quadratic equation. All right, so again, when you have the option of factoring, always try to do that first because that's the easiest way to solve a lot of quadratic equations. But again, it doesn't always apply. You'll see that soon in the upcoming videos. All right, so let's move forward to the next slide. All right, and we're going to be now looking at the square root method. Okay, so for these problems, we're going to use the square root method. And there's a general strategy to apply here. You want to always try to isolate the square first. Then we'll take the square root of both sides of the equation. We'll talk more about the plus or minus in a minute. And then we'll try to isolate the variable to solve the equation. So for this very first one, we've got w squared is equal to 4. So what we're going to do is take the square root of both sides of that algebraic equation. And for this first one, we'll be more careful with the details. Remember from the previous note quiz that when you take the square root of a variable and simplify it down, it's going to be the absolute value. So this is really the absolute value of w that's equal to the square root of 4, which we know is 2. And remember now that absolute value equations have a positive and a negative possibility for solutions. So this w is either equal to positive 2 or negative 2. And what we usually do is kind of bypass that middle step and just put the plus or minus onto the answer when we take the square root of both sides. So for the first equation, we get negative 2 and 2 for our two solutions. For the next equation, you will notice that the square has not been fully isolated. So we'll divide both sides by 25 first. And that takes us to t squared equals the fraction 49 over 25. We can now take the square root of both sides of the equation. And we get just t here. And again, we're going to get a plus or minus, again, omitting that middle step. And then the square root of 49, we know is 7. Square root of 25 is 5. Make sure you take the square root of both numbers. So 7/5 and negative 7/5 are the two solutions for that quadratic equation. All right, now let's move on to the next, and we'll kind of keep building up our difficulty here. For the next equation, you will notice that I first need to isolate by subtracting 33 from both sides. That's going to take me to 3x squared equals negative 33. I can divide both sides by 3 now to simplify. I get x squared equals negative 11. Just like before, we now take the square root of both sides. And be very careful. The square root of x squared is x. But now remember, when you take the square root of a negative, it's not going to be a real number. It's imaginary. The square root of 11 is going to stay the square root of 11 because we can't simplify it. But the square root of negative 1 is replaced with I. So here we've got positive and negative. Be very careful, by the way. Yes, do not put the I inside the radical. Be super careful with your writing. All right, so for the next problem, you will notice that I need to first move that 3. So we'll add 3 to both sides, and that takes us to the quantity 6t plus 7 squared equals positive 3. We now take the square root of both sides of the equation. On the left, we get just 6t plus 7. On the right, we get plus or minus the square root of 3. And now when we subtract, we're going to subtract 7 from both sides. We're going to put it in front of the plus or minus because that negative 7 is not changing sign. We've got 6t is negative 7 plus or minus the square root of 3. The last step is to divide both sides by 6. So we could either split this apart or we can keep it as a plus or minus. In the interest of space, we'll keep it as a plus or minus. Negative 7 plus or minus the square root of 3 over 6. And you will notice that that does not simplify down any further. But again, we could split that apart as negative 7 plus the square root of 3 all over 6, or negative 7 minus the square root of 3 all over 6. And so we'll box up our 4 solutions for that equation, and we will move on to the next page of calculation. All right, so now we're going to move on to completing this square. And completing the square has us trying to get the problems that equations we're trying to solve into the form that we had on the previous page, which is something squared equals a number. And there is a 6-step process for this, and you don't have to do all 6 steps for every problem. Some problems are shorter, and you can kind of jump into the middle steps of the process. But the idea, again, is you should always keep these 6 steps in mind in case you can start off with a general problem. So for here, the first thing you'll notice for problem number 8 is that it does factor, but we're trying to complete the square here, so that is not how we're going to solve this problem. So the first step for this problem is going to be moving the 12 to the other side. So we subtract 12 from both sides of the equation. That takes us to t squared plus 8 times t, leave some room, equals negative 12. Next thing to do is now do the completing of the square. And the idea is you take half of that middle number, which is the b number, and you square it. So half of 8 is 4. 4 squared is 16. So I add the number 16 to both sides of this equation. Once you do that, you will now have a perfect square on the left, which again is something that factors as something times itself. So that's going to be t plus 4 times t plus 4. On the right side, we combine like terms, and 16 minus 12 is just a 4. So this is going to be rewritten then as a t plus 4 quantity squared equals the number 4. And we've now completed the square. We have something squared equals a number. We now proceed with the square root property. We square root both sides. Takes us to just t plus 4. The square root of 4, remember, is plus or minus whatever it simplifies down to, which is 2 here. We now subtract 4 from both sides. And a t is equal to negative 4 plus or minus 2. And we can't keep it that way because there's actually 2 numbers there that we need to figure out. So we take the negative 4 plus the 2 and the negative 4 minus the 2. Well, the negative 4 plus 2 is negative 2. The negative 4, take away 2 more, negative 6. So that's our 2 solutions, negative 2 and negative 6. And we'll box them up, and you will notice if I go back to the original equation, I could have factored this as t plus 2 and t plus 6, and there's my 2 solutions. All right, for the next problem, we're going to complete the square again. This time around, the first step is, the C number step has been done already, which is nice. So we can now just add a number to both sides. We're taking half of the 6, which is 3, and we are squaring it, which is 9. So we're going to add 9 to both sides of the equation. So again, I've got the original x squared plus 6x is negative 15. And I'm going to add a 9 onto both sides. The left side factors as x plus 3 quantity squared. The right side, negative 15 plus 9 makes a negative 6. I can now square root both sides. And I get x plus 3 equals plus or minus the square root of 6 times I. Subtracting 3 from both sides and putting it in the front where it belongs, I get x is equal to negative 3 plus or minus the square root of 6 times I. And that is the solution for that quadratic equation. All right, moving on to the next problem, you will notice that I'm not leading off with a 1 this time. I have a 2 in front of the square. And we need to move that 2 out of there so we can complete the square. Right now, it won't factor nicely as a square, so we have to get it out of there. So we're going to divide the entire equation by that 2. That's going to take us to positive m squared minus 7 halves m minus 2 equals 0. Now we can move the 2 over. So we've got m squared minus 7 halves m, leave some space, equals 2. Off to the side, we're going to have to take our negative 7 halves and we're going to have to take half of it. Well, to take half of a fraction, you just multiply the fraction by a half. So that's a negative 7/4. So that's the halving part. Now we got to square it. Squaring that out is going to make 49/16. So that's the number we have to add to both sides here to complete the square. Again, it's 49/16 on both sides. Always the same thing to both sides. All right, next step is to factor. Don't be intimidated by the fractions there. It's going to be an m times an m. That makes an m squared. And it's got to be a minus because the middle sign is a minus. A little small there, so let's make it bigger. And something times itself, that makes 49. Well, that's 7. Something times itself, that makes 16. That's a 4. So that's my factorization. And you will notice that that same number shows up every single time. Off to the side, I've got some fraction adding to do. I take my 2 plus my 49/16, make it a 2/1, multiply by 16/16. That's going to be 32 plus 49/16, which does add up to make 81. So that's 81/16. Now that we've completed the square, we can use the square root property. So square root both sides. That's m minus 7/4 is equal to plus or minus. Square root of 81 is 9. Square root of 16 is 4. Adding the 7/4 to both sides, I end up with m is equal to 7/4 plus or minus 9/4. Just like before, we can simplify that down to actually nice fraction numbers. So that's 7 plus 9/4 and 7 minus 9/4. Well, 7 plus 9 we know is 16. So that's 16/4, which is just plain 4, one of our solutions. The other one, 7 minus 9, is negative 2/4, which reduces down to negative 1/2. So that's our two solutions for that quadratic equation. And again, the idea behind completing the square is to turn your polynomial into the square by moving the constant to the other side, dividing the a number to the other side, taking half the middle number, squaring and adding, and factoring. So again, there's 3 really good examples of that process. For these next problems, we're going to use the quadratic formula. And just like before, it's always really important to make sure that you have your equation in that general form, which is some number times x squared plus some number times x plus some other number, necessarily not that different, equals 0. And this formula here is the result of using the completing the square process on the general quadratic. So for these problems here, the most important thing for us to do is always identify clearly who the a, b, and c are, plug everything in so that we can see all the details, and then simplify down very, very carefully. So for this first problem here, I'm going to first label everything. And so for the first one, I have a equals 1, b is equal to negative 7. Make sure you include those signs, and c is negative 7. All right, now using my quadratic formula, my variable I'm solving for is x. That's the negative or opposite of b, so that's the opposite of negative 7, plus or minus square root of negative 7 squared, minus the 4, which is always there, times the a, which is 1, times the c, which is also, coincidentally, negative 7, all over 2 times 1. Now we just simplify down very carefully. So it's going to be positive 7 plus or minus inside the square root. 7 squared is 49, always positive, plus 28 over top of 2. 49 and 28, well, they're not the everyday numbers we see, so let's just going to add them up on a little mini calculator. It's like 77. So this is going to turn into 7 plus or minus the square root of 77 over 2. And that 77 does not break down. There's no perfect squares going into it. So that's my two solutions. 7 plus or minus the square root of 77 over 2. And again, for a homework system, you may have to separate that with one with the plus and one with the minus. But for us, we'll just leave it in this form. For the next equation, you will notice that the form is not right because it's got terms on both sides and it's not equal to 0. It's always easiest to move everything over so that you have a positive leading coefficient. So I'm going to add 2x to both sides. And I'm going to add 7 to both sides as well. When all of that dust settles, we're going to end up with the following quadratic equation. We're going to have a 2x squared plus 2x plus 7 equals 0. Once again, we read off the A, the B, and the C numbers. This time around, the A is 2, the B is coincidentally 2 as well, and the C is positive 7. So when I solve my quadratic equation, I'm going to have negative B, which is negative 2, plus or minus square root of 2 squared minus 4 times 2 times 7. That's my 4AC again. All over 2 times 2. Simplifying this down, I get x is negative 2 plus or minus, and inside the radical, that is 4. Take away 56 all over 4. Well, that's actually a negative 52 over 4. I can break that down because I know a perfect square that lives inside of 52. It is namely 4. So that's the square root of 4 times 13 times a negative 1 all over 4. So that's a negative 2 plus or minus. The square root of 4 is the number 2. Square root of 13 is stuck that way. And the square root of negative 1 makes an I all over 4. And then we can reduce down. We can divide everything by a 2. So I'm going to get a negative 1 plus or minus square root 13 I all over 2. And that is my two solutions for that quadratic equation. Okay, for this next equation, once again, we're going to use the quadratic formula. This time around, you should notice that it's not in the general form like the previous problem. So we're going to first multiply and distribute out. So it's really a w squared minus 2w equals negative 5. Then add the 5 onto both sides. Takes us to w squared minus 2w plus 5 is equal to 0. Once again, listing out the a, b, and c. A in this case is 1, b is negative 2, and c is positive 5. So the variable w I'm solving for is going to be the opposite, or negative, of b. So negative 2 plus or minus square root b squared, which is negative 2 squared, minus 4 times 1 times 5. That's my 4ac all over 2a, which is 2 times 1. Simplifying down, that's now a positive 2 out front inside the square root. That is the square root of 4 minus 20, which is negative 16, all over 2. Simplifying this down, that's a 2. The square root of negative 16, remember, is going to be 4 and I. That's all over 2. When I simplify, I now divide that 2 into both of those numbers. So w is actually going to be 2 over 2 plus or minus 4i over 2, which is really 1 plus or minus 2i. So that's the solution for that quadratic equation there using the quadratic formula. And again, we could have either used this or the completing the square method. When it doesn't tell you how to solve it, you're welcome to use whatever seems easiest and it gives you the less amount of work. However, when it's prescribed like these notes here, make sure you always use the method that's being mentioned and specified. All right, so now we're moving on to talking about describing quadratics. The goal of these problems is not to actually solve the quadratic equation. Instead, is to determine the type and the number of solutions to expect. For quadratics, you're either going to get two different solutions, a repeated solution, or no solution. Well, you always get some solution. It just may be imaginary. But the idea is that most you'll get two. And again, there's different types of numbers based on what you get. And if you think about this, the last several problems we've done, sometimes there's i's showing up. Sometimes you get nice clean fractions. Sometimes you get answers with weird radicals in them. So it really depends on what's inside of that square root. Whatever it turns into gives you that final outcome. That stuff inside the square root is called the discriminant. It's probably an unfortunate name, but that is what we call this thing in mathematics. And it's always, again, the inside of the square root, which is b squared minus 4ac. And of course, you always have to make sure you're in standard form before you identify the a, b, and c. So for this first problem here, we've got negative 4w squared plus 9w. And you'll notice that the 5 is on the other side. It's not equal to 0. So when I subtract 5 from both sides, I'm going to get minus 5 equals 0. I now know that a is negative 4, the b is positive 9, and the c is negative 5. So when I find my discriminant, I'm going to get d is equal to 9 squared minus 4 times negative 4 times negative 5. Well, 9 squared is 81. The product of three different negative numbers is negative, so there's going to be a minus there. And then I'm going to get 16 times 5, which is 80. So I get 1 for my discriminant. Now I go up to my little chart up at the top and say, well, how does 1 qualify? What kind of number is it? Well, we know it's greater than 0. And we know it's a perfect square because 1 squared is 1. Because of that, we're going to get two solutions. And again, that's what's important here. Two solutions, and they are rational numbers. Which means that if I was to solve, I would have no square roots in the final answer. And I wouldn't have i's either. I would just have plus or minus fractions. They're nice, clean numbers. For the next problem, we're going to go through and find that discriminant as well. My d is going to be equal to b squared minus 4ac. So the b is negative 7 this time. So that's squared. Minus 4 times the a number, which is 5, and the c number, which is 3. So that's going to be 49 minus 60. And we know that's going to be a negative number. That's going to be negative 11. That number falls into the second part of our table. It's a negative number. Now again, keep in mind, negative 11 is not our solution. We're looking at just using a litmus test to find out what kind of numbers we get. So we're going to get two solutions, and they're going to be complex or imaginary, if you will, because we have a negative discriminant. For this last problem, we need to first change the order around. So that's negative 6.4 n squared plus 4.8 times n plus 0.9 now equals 0. Actually, wait a minute. We move that over and that becomes a negative 0.9. Be very careful when you move stuff around. We're actually subtracting it from both sides. Once again, we find our discriminant. That discriminant is going to be b squared, so that's 4.8 squared minus 4 times the a number, which is negative 6.4, times the c number, which is 0.9. And when you plug this into a calculator, you get 0. Again, 0 is not a solution. We go to our table instead and see that d equals 0 gives us one rational solution. Again, the discriminant tells us what we're going to expect for types of answers and never tells us the actual answers. All right, so now we're going to move on to a couple miscellaneous equations that are quadratic in a form. The idea for these is just to isolate the variable using one of the previous methods we talked about in this note pack. So you will notice here that for the first one, I'm going to solve for r, which means I need to isolate the r squared. So just like before, I'm going to divide both sides by what's being multiplied, divide both sides by pi. That takes me to r squared is the fraction a divided by pi. So now we can use the square root property because that's the quickest way to get r by itself. Taking the square root of both sides, that gives me r is equal to typically plus or minus the square root of a over pi. But because of the disclaimer that r is greater than 0, it's just the square root of a over pi that equals out to r for this case. We can throw away the negative solution. And if you think about this is the area of a circle, of course the radius is going to be positive. For the next problem, we're going to go through and solve for x. You will notice this time around that it's not in the standard form. So we're going to subtract z from both sides to get it equal to 0. So this is now 1/2 g times x squared plus k times x minus z equals 0. And for a problem like this, it's a really good idea to identify who the a, b, and c are. So the a in this case is what's in front of the x squared. It's the 1/2 g. The b is just the number k. And the c, make sure you include the sign, is negative z. So my solution x is going to be negative b, so negative k, plus or minus the square root of k squared minus 4 times the a, which is 1/2 g, times the c, which is negative z, all over 2 times the a, which is 1/2 g. Simplifying this down, I get a negative k leading off my answer. I still have my plus or minus, and inside I've got a k squared. And I can simplify down. That negative times negative is going to make a plus. 4 times 1/2 is a 2, and g times z is pretty much g times z. And then down below, 2 times 1/2 g is just plain g. And because there's no disclaimers here on any of the variables and what to expect, we just leave it as is. So it's negative k plus or minus square root of k squared plus 2gz all over g. And again, this does not simplify down any further. All right, so for the next problems, we're going to be moving on to rational equations. And rational equations are really nothing more than equations that have fractional components to them, either polynomial parts or just numbers. And so unlike the problems we did last week where we were adding and subtracting fractions to make more fractions, when you're solving equations, the goal is to actually get rid of those fractions. To do that, we always find the LCD, we multiply the entire equation by the LCD, we distribute and cancel. Once you do that, you should have no fractions left. And then at the end, you must always go back and check your solution if you have a variable in your denominator, because we don't want to divide by 0. Those solutions are called extraneous solutions. So for this first problem, it's actually a throwback problem from beginning algebra. We want to go through and first find that LCD, which again is the smallest quantity that all of your denominators go into. So my LCD needs to have 5 go into it, and it needs to have 6 go into it. Well, the smallest thing they have in common is 30, and the 2 does go into 30, so 30 is my LCD for this problem. I now multiply both sides by that number 30. So I'm going to multiply the left by 30 and the right by 30. Some people find it beneficial to put those over a 1 to keep them lined up. And now this is the part that you be very careful with. We now distribute that 30 to both things on the left. So that's actually 30 times the h minus 4 that's there over top of 5. Then that same 30 is going to hit the h minus 8 over top of the 6. And over there on the right, well, half of 30 we know is 15. Next thing to do is cancel down what you can. And again, at this point in the problem, there should be no fractions left. Otherwise, we multiplied wrong or have the wrong LCD. So for this first problem, 30 divided by 5 is a 6. For the second term, 30 divided by 6 is 5, and we already reduced the right. So that's really parentheses 6 times h minus 4 minus 5 times h minus 8 is equal to 15. We can now distribute, get a 6h minus 24 minus 5h plus 40 is equal to 15. We now continue our work over here. 6h minus 5h just leaves one single h. Minus 24 plus 40 makes plus 16. And it's equal to 15. Subtracting the 16 from both sides, I end up with h is equal to a negative 1. And again, because we just had fixed numbers for denominators, there's no need to go back and check this. But again, when you have a rational equation, you should always be careful at the end to not keep a bad answer. All right, let's move on to the second problem. Here you will notice that my LCD is going to be more complicated. The first fraction requires a 2. The second one requires a 2 and an h. So 2h will take care of the first two. The third one needs an h, so it is covered, but the last one needs a 4. So we need to take 4h to multiply by. So for this problem, my LCD is 4 times h. Just like before, I'm going to multiply both sides by 4h. And then I'm going to distribute. So for the first equation, 4h times 5 is 20h over 2. For the second term of the equation, 4h times 3 is 12h over top of the 2h already there. On the right-hand side, I have 8h times 4h makes 32h over top of the h already down there. And then finally, I'm going to have 4 times 9, which is 36h over 4. Again, at this point in the problem, everything should cancel out. So you will notice here that for the first one, I'm going to get 10h. For the second term, I'm going to have the h's cancel. 12 over 2 is 6 for the right-hand side. 32 is left, h's cancel. And then 36 divided by 4, of course, is 9. So minus 9h. I now combine like terms. I'm going to add the 9h onto both sides. And I'm going to add the 6 onto both sides. That gives me 19h is equal to 32. That makes 38. Divide both sides by 19. That goes in evenly. I get h is equal to 2. Now again, before I get happy and just go running with that 2 that I got, I have to make sure I check for extraneous solutions. This time around, I wouldn't want h equals 0 for my answer, because dividing by 0 is undefined in mathematics. But 2 doesn't do that. 2 stays a 2. All right, last problem on this page, we're going to go through and divide by y minus 7 a couple times there. So just like before, we want to get rid of the fractions. We're going to find that LCD again and multiply by it. The first equation, or I should say the first term of the equation, takes y minus 7. The second is really just a 3 over 1, so it needs nothing. And then on the right-hand side, that's still y minus 7, so we're good. Our LCD is just y minus 7. And again, I multiply that on both sides of the equation, and I'm going to make sure I distribute when I multiply it. All right, so for the first one, when I multiply, I'm going to get 7 times y minus 7 over top of y minus 7. In the second term, I've got a 3 already there. Picking up a y minus 7 from distributing, still over top of 1. Other side, 10 times y minus 7, sitting over top of y minus 7. Just like we said before, these fractions are now going to all cancel out. And we end up with 7 times y minus, actually no, it's just plain old 7. My bad. That's just a plain old 7 from the first because the y minus 7s are gone. Then we get a 3 times y minus 7. And on the right, got a 10. So that's going to be... All right, so we now distribute, and we're going to get 7... Oh, wrong color. We're going to get 7 plus 3y minus 21 is equal to 10. We now can combine like terms. So 7 minus 21 is negative 14. So that's 3y minus 14 is equal to 10. We now add 14 onto both sides. We end up with 3y is equal to 24. Divide both sides by 3. And that gives us y is equal to 8. And you will notice if I substitute 8 back into the original equation, 7 divided by 8 minus 7 is just 7 over 1. And 7 over 1 plus 3 makes 10. And if I plug in 8 on the right side, 8 minus 7 is 1. 10 over 1 is 10. So it checks out. They make 10 on both sides. So y is equal to 8. And that is the solution of my rational equation. And again, please don't box up any answers until you get to the point where you check them to make sure that they keep your expressions defined. If they make you divide by 0, we have to throw out those solutions. And again, we'll see that in a coming problem or two in a few minutes here. All right, so for this next page, we're going to continue solving rational equations, and we're going to be stepping up the difficulty on them to make sure that we have a variety of problems we know how to solve. So for this first one, we're going to go through and find the LCD, multiply by the LCD, and then clear it out. So for this first one, that LCD that we build is going to have to first require a k in it for the first term, and then the second term wants a k minus 6. Remember again that LCDs are built by multiplication. We don't add or subtract to build them. So for the left-hand side, we multiply by k and k minus 6. Same thing is true on the right-hand side, k and k minus 6. In the interest of space, I will now distribute and cancel at the same time. Remember, that k and k minus 6 hits all the terms. So in the first one, the 25 is going to be there. I get a k minus 6, but the k's are going to cancel out. In the second term, the 25 is there. The k is going to show up, and the k minus 6's are going to cancel out. And then on the right-hand side, the 3 is already there. The k will cancel, and I'm left with the k minus 6. Just like before, I will multiply this out. So I have a 25k minus 6 times 25, which is 150, minus 25k equals 3k minus 18. It's a coincidence in this problem that the 25k's will cancel out. And then I can add my 18 onto both sides. That will take me to 3 times k equals negative 132. And then divide both sides by 3. And I get k is equal to whatever 132 divided by 3 is, which is 44. So I get negative 44. Now, before I really go running with this solution, I just check to make sure that it's not going to be not permitted, not extraneous. For this one, I wouldn't want to keep a k equals 0 or a k equals 6 for a final answer. And negative 44 is neither of those. For the next problem, we're going to continue on finding the LCD and multiplying it. The first fraction takes x squared. The third number, or I should say the 6 over 1, it takes nothing because it's already a 1. And then the x is covered by the x squared, so we're good. That's our LCD. Just like before, multiply both sides by the x squared. And don't overshoot those parentheses. All right, so on the left side, 5x squared over x squared is just 5. On the right side, I get a 6x squared. And then when I distribute that x squared to the 1 over x, remember again, I'm distributing, I'm going to get just minus x. If I now bring everything to one side, I get 6x squared minus x minus 5 equals 0. And again, most of these problems are now going to factor because we've done the hardest part already. So let's split that apart. That's going to be a 6x squared. I'm going to use the AC method. So 6 times 5 is negative 30. And the difference of 1 is 6 and 5. So that's going to be a minus 6x plus a 5x minus 5 equals 0. Factoring by grouping. In the first, I can take out a 6x, leaves me with x minus 1. In the second, I can take out a 5, leaves me with x minus 1 equals 0. So that's x minus 1 times 6x plus 5 equals 0. Earlier in the note packet, we saw that you can set both those factors equal to 0. So x is one solution, possibly. And then subtracting 5, I get 6x equals negative 5 divided by 6, negative 5, 6. So 1 and negative 5, 6. Again, the one solution you wouldn't want here is 0 because substituting 0 in place of x would force you to divide by 0. All right, now let's move on to the next one. For this next problem, we first find the LCD. You'll notice it's going to need a lonely 5 and an h minus 5. Just like before, I multiply both sides by that LCD. So that's 5 and h minus 5 on both sides. Remember again to distribute before you cancel. So when I distribute, I'm going to go through, and for the first part, I'm going to have 5h, h minus 5 over h minus 5. And we know that the 5 is going to stay. The single h that's already there is going to stay, and the h minus 5s cancel out. In the second term, it's going to be the 5 and the h minus 5 up top over top of a 5. Leaves me with just h minus 5. And on the right side, I'm going to have the two 5s multiplying to make a 25. But the h minus 5s are going to cancel out. So combining like terms, I get 6h minus 5 equals 25. Adding 5 to both sides, I get 6h equals 30. Dividing by 6, I get h equals 5. And finally, we get into some trouble because you can't substitute 5 back in the original because you're dividing by 0. So since the one number that you got is no good and does not work, you have to cross it out, and we have no solution for this rational equation. And what that really means is that no matter how hard you try to find a number that works, you never will. This equation basically false from the start. All right, so let's move on now to our next equation. Think of this as the grand finale of the rational equations because it is a very, very long equation. We have to go through and find the values of h that make this equation true. And the first thing you should observe here is that you can't just find an LCD by looking at it. So instead, what we want to do is factor everything down first to see what we're working with. So it factors as -7, and then down below, that's going to be an h minus 1 and an h minus 2. In the middle term, I got a 5 upstairs. That's going to factor into an h plus 2 and an h minus 1. And then on the right-hand side, that's the difference of squares, h plus 2, h minus 2. Now I'm going to build that LCD. And the first term requires those two there, h minus 1, h plus 2. The second term has the h plus 2 already there. Actually, I didn't do that right. That factors as h minus 1, h minus 2. So the first one actually needs an h minus 2. All right, so let's put that there, minus 2. All right, for the second term, the h minus 1's already accounted for, but it now wants an h plus 2. And then the last term, or the right-hand side, if you will, it's got the h plus 2 and h minus 2. So we found the one smallest thing that covers all three denominators. And again, the first one is captured by the first two factors. The second one is captured by the first and third factor. And then the last one is captured by the second and third factor. So we are good. We are now going to multiply that LCD to both sides of this equation. All right, so on the right side, we've got the h minus 1, h minus 2, and h plus 2. On the left side, we will cram in the best we can h minus 1, h minus 2, and h plus 2. Cram those all in. So now that's going to distribute to both of our terms on the left side. So again, in the interest of space, because you can see we're running out of it quickly, the -7 is going to be there. And then we'll distribute all three of those to the top. The h minus 1's and the h minus 2's are going to cancel, but I'm left with the h plus 2. It's still there. And then for the second, the -5 is there. This time around when I distribute, the h minus 1's are going to cancel, the h plus 2 is going to cancel, but I'm going to pick up the h minus 2. And then on the right side, the 10's already there. The h plus 2 is cancel, the h minus 2 is cancel, and I'm picking up an h minus 1. I should now be fraction free, and I can just distribute. So that's -7h minus 14 minus 5h plus 10 is 10h minus 10. Combining like terms, that's a minus 12h minus 4 is equal to 10h minus 10. Just like before, we will combine like terms by subtracting 10h from both sides and adding 4 onto both sides. When the smoke settles, we've got -22h is equal to -6. Dividing both sides by -22. I get h is equal to 3/11. So 3/11 is my solution. You will notice here that I do not have a 1, a 2, or a -2, so I am good. I will not be dividing by 0 with that solution there. All right, now let's move on to our last of these rational equations before moving on to other topics. So for this one, the idea is to isolate the variable. To do that, we want to have it in the form of t equals something without t's in it. And it's really just a rational equation. First thing I'm going to do is multiply both sides by t. And if you want to put it as t over 1, that's fine. Doing that, I will get t times k equals I times r. And then to get the t alone, just divide both sides by capital K. And I get t is equal to I times r over k. And that is solved because I have now isolated the t for this equation. Next up, we're going to move on to radical equations. And you'll see that for the most part, they're a little shorter than some of these rational problems. All right, so moving on to equations with radicals, the idea for these problems is to go through and try to isolate the radical by doing algebra. Either square or cube both sides to eliminate the radical, and then solve the equation and check your answer. So that's going to be our strategy for the next several problems. So for this first example here, what we're going to do is isolate the radical. To do that, we will subtract 2 from both sides, and we get the square root of k equals the number 1. So to undo a square root, we are going to square both sides of the equation. When you square the square root, they're inverse operations and they cancel out, and then 1 squared happens to be 1. And don't forget, you're solving the equation. If you go back and check, it does make it true. The square root of 1 plus 2 does make 3. All right, let's move on to the next equation. Once again, we're going to isolate the radical. So this time, we are going to add 5 onto both sides. Changing the order around, that gives us the square root of 9 plus 6 times a is equal to 8. Once again, we want to eliminate the square root. So we're going to square both sides. Squaring the square root cancels it out, so we get 9 plus 6 times a, and then 8 squared is 64. We now subtract 9 from both sides. That gives us 6 times a is equal to, let's say, 55? Sure is 55. Divide both sides by 6. And a is equal to 55 over 6, which is a non-reducible fraction. All right, let's move on to problem number 29. In 29, you will notice it's a cube root problem. Just like before, we're going to isolate the radical first. So we add 2 to both sides. So that takes us to the cube root of x minus 2 is equal to the number 6. Well, using your intuition, to get rid of a cube root, we cube both sides, or raise both sides to the 3rd power, if you will. So that simplifies down to x minus 2, and 6 cubed is 216. Adding 2 onto both sides, you get x is equal to 218. It should be noted that you don't have to check solutions for cube root problems, because when you cube a cube of a negative, or cube a cube root, or a cube root a perfect cube, you get negatives preserved. So we're going to keep those answers. It's the squaring or the even powers that give us the trouble. Speaking of, let's move on to problem number 30. First step, isolate the radical. So if we subtract 2 from both sides, we're going to end up with the square root of x plus 17 equals negative 2. So if you're on your toes with algebra, you will notice here that, okay, something's going on that's not very good. But again, let's just kind of follow our, not follow our intuition, and just keep on moving along. So I'm going to copy this over again so I can talk about it later without wrecking it. All right, so once again, I got the square root isolated. I'm going to square both sides. That takes me to just plain x plus 17. And I know that negative 2 squared is positive 4. Subtracting 17 from both sides. And I get x is equal to a negative 13. And if you go back to the equation and substitute it in, that original equation was 2 plus the square root of x plus 17 equals 0. So if we take our solution and substitute it in, you will notice something kind of interesting. We still have a 2 plus in front of the equation, But negative 13 plus 17 is 4. So that's the square root of 4. So you're telling me that 2 plus the square root of 4 is going to make a 0. And it doesn't, because that's 2 plus 2, which is 4. And again, that is not equal to 0. So that negative 13 we got is no good. We do not want to keep it. So we're going to toss out the one answer we got, and we're going to write down no solution again. And at this point, you might be thinking, well, yeah, that's a lot of work to get no answer, which does happen sometimes. But what's more important is going back to the original problem and noticing that I'm going to try to force the square root of a number to equal a negative. And again, from either intermediate algebra or introductory algebra, square roots with the radical symbol only give you positive numbers because they are the principal square root. So this by itself right here, this was already a contradiction. You cannot find two numbers that multiply to make a negative 2 that are real numbers. So you can't take the square root and get a negative for an answer. This is different again from what we did earlier when you square rooted both sides. Square rooting as an algebraic process gives you a plus or minus, but when a problem starts off with the square root of something equals a number, that number can't be negative. So very important to make sure you just draw that distinction there because we're doing a lot with square roots and squares in this note packet. All right, so let's move on to the next problem. And this problem, you'll notice, has a lot more steps to it because it has square roots and now two terms instead of just one term. So just like before, the very first thing we want to do is we want to isolate the radical. So that means for this problem, we're going to add 6 onto both sides. In doing so, we end up with the square root of t plus 18 equals t plus 6. So that square root has been isolated. The next step is to square both sides of the algebraic equation. So on the left, you do get a t plus 18 because the square root cancels. On the right, however, be very careful. That is t plus 6 times another t plus 6. We can't just throw around that 2 onto the t and 6 because we won't get the right amount. So t plus 18 is now equal to a FOIL calculation. The first multiplies the t squared, outside 6t, inside 6t, last 36. So that's t plus 18 is equal to t squared plus 12t plus 36. We now need to move all the terms to one side because we have a quadratic. So we subtract t from both sides. We subtract 18 from both sides. And that takes us to positive t squared plus 11t plus 18 is equal to 0. And again, as we said earlier in this note quiz, these are going to almost always factor. In theory, they don't have to, but in a nice classroom setting, they always factor. Two numbers that multiply to make 18 and add up to 11 are 2 and 9. So that's t plus 2 and t plus 9 that multiply to make 0. So t plus 2 is 0, or t plus 9 equals 0. So t is either negative 2 or t is equal to negative 9. For square root equations, you can get a lot of possibilities. You can get 2 answers, 1 answer, or no answers at all. But in any case, because we squared both sides, we have to do a quick check to make sure that we have 2 good answers. And if not, we got to throw one or both out. So let's first check out t equals negative 2. I said negative 2, not positive 2. All right, so again, we are checking t equals negative 2. Substituting into the left side, that's the square root of negative 2 plus 18. Subtract 6. Let's see what that gives us. Well, the square root of negative 2 plus 18 is the square root of 16 minus 6. So that's 4 minus 6, and that does equal negative 2, which is t. So that solution checks, and we're pretty happy about it. Now let's check out the negative 9. Again, that's the square root. This time it's negative 9 plus 18 minus 6. That turns into the square root of 9 minus 6. And remember, the square root ends at the 9. So that's going to be the square root of 9, which is 3 minus 6, which is negative 3. And that is not equal to the t number, which is negative 9. So that solution is no good, and we toss it out. The one good answer we got this time is t equals negative 2. And again, remember, it's possible to have both numbers not work or both numbers work as well. There's no rule that says which ones are going to be good and bad. You just have to substitute them in and try it out. All right, so move on to the next problem. The next problem is kind of a doozy because you will notice here that it's got 2 square roots. And typically, the number of radicals in the problem usually tells you how many times you have to either square or cube something. But again, if we just follow our nose and do what we're told, we'll be fine here. So the first thing you want to do is isolate a radical. So we'll keep the square root of a plus 11 intact, and we will actually add the square root of a to both sides. So that's the square root of a plus 11 equals the square root of a plus 1 when I move it. Just like before, I'm now going to square both sides. So that makes a plus 11, and that's the square root of a plus 1 times itself. Remember, that's what squaring means. So a plus 11 is equal to the square root of a. I'll just write it out. That's the square root of a squared. And then we get 1 square root a plus another 1 square root a, and then 1 times 1 is 1. Simplifying and combining like terms, the square root of a squared is just plain a. Square root of a plus square root of a makes 2 square root a's plus 1. In this problem, it's a pure coincidence, but you can subtract a from both sides and subtract 1 from both sides. On one side, you're left over with 2 square root a. On the other side, you're left with 10. We can now divide both sides by the 2 to isolate the radical. I get the square root of a is equal to 5. I now square both sides. And I do get a is equal to 25. Once again, that is a candidate for my solution. I have to go back and check it out. If I substitute that in, that is the square root of 25 plus 11 minus the square root of 25. That is the square root of 36 minus the square root of 25, which is just 6 minus 5. And yep, that does equal 1. So we are happy. So our solution of a equaling 25 is a good solution. And we can box that problem up and call it a day. All right, so that's the last of our square root equations. We are now going to move on to our equations that are reducible to quadratic. So let's do those next. All right, for equations reducible to quadratic, the idea is that we have equations that aren't quadratic, but they can be rewritten to become quadratic with a substitution. And the whole spirit behind this is really thinking about what it means to be quadratic. You know, we commonly see ax squared plus bx plus c, but that's really a times any variable you want squared plus b times that same variable plus a number c equals 0. And again, we commonly see x in the spot of the square. But again, it could be anything. It could be t's, it could be y's, it could be other expressions. So in this case, you're looking for the same thing. And you will notice that you have something in the middle that is being squared in the first part of the equation. So what you do is you take that middle part and we're going to swap it out. We're going to let some other letter besides what's in the equation. So we're going to pick u to be m squared minus 1. And in that case, if I square both sides of this, u squared is m squared minus 1 quantity squared. So where I see the m squared minus 1 squared, I can just rewrite that as a u squared. The 2 is already part of the equation. I just copy it down. The m squared minus 1, I swap out with a u. The minus 15's already there, and I end up with a nice little quadratic equation. Again, most of the time, these are going to factor very nicely because the hard part is making the substitution, and we don't want to throw everything at you all at once. So it does factor. It factors as u plus 5 and u minus 3. So either u plus 5 equals 0 or u minus 3 equals 0. So u is negative 5 or u is 3. Well, I hate to break it to us, but we didn't want u's. We wanted m's this whole time. So we now swap out the u with what it was, which was m squared minus 1. That's equal to negative 5. Or it's that same m squared minus 1 that equals out to 3. And then we can solve both of these little equations. I can add 1 to both sides. The first one becomes m squared is negative 4. The other one, when I add 1 to both sides, I end up with m squared is equal to positive 4. And then I can square root both sides like we did earlier in the notes. And I get m for the first one is equal to plus or minus. The square root of 4 is 2. And the square root of negative 1 is I. For the other, square rooting both sides, I just get plus or minus 2. So my two solutions are negative 2i, 2i, negative 2, and 2. 4 solutions for that equation. Now let's move on to the next equation. Again, the same idea as before. You want to see something in the middle that's being squared to create the first. And so that middle part, it's kind of hard to see here with this font, but it is x to the 1/3. So I'm going to let u equal x to the 1/3 power. And then if I square it, u squared is x to the 1/3 squared, but that is a 2/1. That's x to the 2/3. So everywhere I see an x to the 1/3, I'm going to swap it out with the u. Everywhere I see the x to the 2/3, I swap it out with a u squared. Rewriting over again, that is u squared minus u minus 12 equals 0. Once again, this equation factors very nicely. It's u minus 4 and u plus 3, that's equal to 0. So either u minus 4 equals 0 or u plus 3 equals 0. So u is 4 and u is negative 3. But again, we didn't want u's, we wanted x's this time. So what we do is we swap out what the x or the u was. So since the u is x to the 1/3, we rewrite this as x to the 1/3 equals 4. Or it's x to the 1/3 equals negative 3. Well, if you're a little rusty with your fraction exponents, don't fear. We can just rewrite that as a cube root. It's really the cube root of x that equals 4, or it's the cube root of x that equals a negative 3. Just like before, we can now raise both of these to the 3rd power to get our solutions. For the first one, 4 to the 3rd power is 64. For the other one, negative 3 to the 3rd power is negative 27. So that's my two solutions. And it looks like my little answer box is gone, so I'm going to just draw a box around those two and be done with that problem. Again, cube roots, no need to check them. They always work as long as your algebra is correct in the process. All right, so move on to our next page. And our next page is our last two problems. So let's go through and solve these. And again, the idea is to use a substitution. You will notice here that this first problem could also have been done by isolating the radical and squaring both sides. But again, let's use that substitution idea instead. So first thing I'm going to do is notice that if I take the square root of p as my u and I square both sides, then regular p is just u squared. So writing this problem over again, p is just u squared. The 6 is copied down. The square root of p is just a u, and that equals 27. Now we're down to a quadratic equation that can be solved a bunch of different ways. Again, you could bring the 27 over and use a quadratic formula. You could just take half the b number and square it and add it to both sides now and get your u that way. Or you could use factoring. So I'm going to use factoring since we haven't seen it in a while. First step is to bring that 27 over to the other side. So this is u squared plus 6u minus 27 equals 0. It's going to factor as u plus 9 and u minus 3. That's equal to 0. Two numbers that multiply to make negative 27 and add up to 6. So either u plus 9 is equal to 0, or it's the u minus 3 that equals 0. So u is negative 9, or u is equal to 3. Now remember, we didn't want u's, we wanted p's. So swapping out the u, we've got the square root of p is equal to negative 9, or the square root of p is equal to 3. And if you think about what we said earlier in this video, the square root of a number can't equal a negative. So this is a dead end that we throw out. And then for the other equation, if we square both sides, we're going to get p equals 9. And if you do take 9 and plug it back in, you'll notice it works because that's 9 for p. The square root of 9 is 3, so 6 times 3 is 18, and 9 plus 18 does make 27. So p equals 9 is a solution for that radical equation. All right, finally, the last problem. It's been a lot of time to get here, hasn't it? So what we're going to do next is use that same substitution idea. This time around, I'm going to pick my u to be w squared. So I'm going to let u equal w squared, and then u squared is w squared squared. And when you raise a power to a power, you multiply. 2 times 2 does make 4. So again, everywhere I see a w to the 4th, I'm going to swap it out with a u squared. 13 is copied down. The w squared is just a u. Minus 48 is copied down. Once again, it factors. This is going to be u plus 16 and u minus 3 that does this. Factor them out. That's u plus 16 equals 0, or the u minus 3 that equals 0. Adding or subtracting, depending on the problem. This is going to be u equals negative 16, or u equals positive 3. But again, we didn't want the variable u. We wanted w's. So we swap it out. U is the same thing as w squared, and that's still equal to negative 16, or w squared is equal to the number 3. You will now notice we can square root both sides, and we'll just kind of do it like a little machine. So for the first, the square root of the 16 becomes a 4. Don't forget that very important plus or minus. Remember, when you square root both sides, plus or minus goes on. So again, square root of 16 is 4, square root of negative 1 is I. Over here, square root of 3 does not simplify, so you just get plus or minus the square root of 3. So your four solutions are negative 4i, 4i, negative square root 3, and positive square root 3. And again, we expect four solutions here because this is a fourth degree algebraic equation. It's a fourth degree polynomial, to be technically correct. And again, those whole number powers will tell us in weeks ahead how many solutions to expect. So again, for these reducible to quadratics, you always find that middle quantity. Let it be a variable. People commonly pick u's for it. Rewrite it, solve it by factoring or some other method, and then make sure you replace back the original variable and then solve for it. And that should get you to however solutions you expect, which is sometimes 4, sometimes 1, sometimes 2, you never know. So thanks for watching, and hopefully everything goes well for you.